All right, in this video, we're going to talk about section 1.6 dealing with other types of equations. So far we talked about linear equations, and also we talked about quadratic equations. So here in this video, we're going to be dealing with other types of equations. So in this section, we're just going to be solving polynomial equations by factoring. And these are going to be higher order polynomial equations that we'll be dealing with. And then we're going to be solving radical equations, and then solving equations with rational exponents, and then solving equations that are quadratic in form, and then solve equations involving absolute value. So those are the other types of equations that we will look at in this video and in this section. All right, let's talk about polynomial equations. A polynomial equation is the result of setting two polynomials equal to each other. Okay. And the equation is in general form if one side is 0 and the polynomial is on the other side in descending powers of the variable. And then the degree of a polynomial equation is the same as the highest degree of any term in the equation. So like in these few examples that I have here, like 3x plus 5 is equal to 14. This is an equation of degree 1. Here the highest exponent in the x is the understood 1. And we call those linear equations. We did do some linear equations back in section 1.2. And then 2x squared plus 7x equals 4 is an equation of degree 2, because the highest exponent is a 2. And we call those quadratic equations because that polynomial equation is of degree 2. Now this next equation does not have a special name for it, but here's x cubed plus x squared equals 4x plus 4. That's an equation of degree 3. Because here the highest exponent there is a 3. Okay. All right, now we're going to be solving polynomial equations of degree 3 or higher. And here's the procedure for that. So some polynomial equations of degree 3 or higher can be solved by this. Number one, you want to move all the terms on one side, thereby obtaining a 0 on the other side. And then number two, you want to factor the polynomial completely. You have to use various techniques for factoring polynomials. And then you're going to set each factor equal to 0 and solve. Okay. So in this case, if we look at example 1, the very first example that you see here, here we got 4x to the 4th equals 12x squared. And here we want to solve this polynomial equation. Well, first of all, we need to get a 0 on one side of this equation. So that means I need to move that 12x squared over to where the 4x to the 4th is. I'm going to do that by subtracting 12x squared on both sides. So that means on the left side, I have 4x to the 4th minus 12x squared equal to 0. And then I need to factor the left side completely. In other words, I need a common factor that's in 4x to the 4th and 12x squared. Well, for the 4 and the 12, the greatest common factor there will be 4. For the x, I use the x term that has the smallest exponent, and that's going to be x squared. And then to get what's inside, we'll do 4x to the 4th divided by x squared, which will be x squared, minus 12x squared divided by 4x squared. That'd be 3. And to check, you can just use a distributive property to see if you did it correctly. 4x squared times x squared will be 4x to the 4th minus 4x squared times 3 will be minus 12x squared. And then next, we're going to set each factor equal to 0 and solve for x. So 4x squared times the quantity x squared minus 3 equal to 0 means this. 4x squared equals 0, or x squared minus 3 equal 0. And then we solve each equation for x. So for the 4x squared equal to 0, if I divide both sides by 4, I'm going to get x squared equal to 0. And to solve for x, it's being squared, so the opposite will be to take its square root on both sides. And I'm not putting a plus or minus symbol there because 0 is neither positive nor negative. Okay, so the square root of x squared is x, equal square root of 0 is 0. And then we got this, x squared minus 3 is equal to 0. Well, if I add 3 to both sides, that would mean x squared is equal to 3. And again, the opposite of squaring something will be to take the square root on both sides. But in this case, I do need the plus or minus symbol because I have a non-zero number there. So that means x is equal to, and I'll leave this as plus or minus the square root of 3. Okay. So my solution will be these x values. X equals 0, x equal to the square root of 3, and x equal negative square root of 3. But if you notice here, the highest exponent is a 4. That would mean I will have to have 4 solutions for this equation. I only got 3. Well, if you look at x squared is equal to 0, if I write this as x times x is equal to 0, and then set each factor equal to 0, set this x to be equal to 0, and set the other x to be equal to 0. Here I have something called a double root. Okay. I have a double root. That means both of these x is going to be equal to 0. So that makes up for the 4 solutions. Because 0 is a double root, I got the square root of 3 and negative square root of 3. All right, here's another example. Now let's say we had this 2x cubed plus 3x squared equals 8x plus 12. And here I want to solve this by factoring. All right, in this case, I'll go ahead and rewrite this 2x cubed plus 3x squared equals 8x plus 12. Now in this case here, I need to move the 8x and the plus 12 by itself over to the other side. So that way I have a 0 on one side of the equation. Well, it's a positive 8x, so I need to subtract 8x on both sides. And the 12 is a plus 12, I need to subtract 12 on both sides of that equation. So the left side would be 2x cubed plus 3x squared minus 8x minus 12 equal to 0. Now those are all unlike terms, so I can't combine on the left side. I just have to write it like that. Now in this case, I got 4 terms. So for me to solve this equation, I need to factor by doing a method called grouping. So in other words, I need to group the first two terms here and group the second two terms and find common factors. So in this case here, for the 2x cubed plus 3x squared, I need a common factor that's in both of these. Well, the only common factor for 2 and 3 is going to be 1. The common variable with the smallest exponent, I can use that. It'll have to be x squared. So I factor x squared out. And then I'm going to do 2x cubed divided by x squared. That will be 2x. And then plus 3x squared divided by x squared would be 3. So inside I have 2x plus 3. On the outside will be x squared. Now for the minus 8x minus 12, I need a common factor that's in minus 8x and a minus 12. In this case, it will have to be 4. But since both of these are negative, I'm going to use minus 4. So I'm factoring out minus 4. And then divide minus 8x by minus 4. This would be positive 2x, because negative divided by negative is a positive. And then minus 12 divided by minus 4, again, negative divided by negative is a plus 3. And then that's going to be equal to 0. Now notice I got the 2x plus 3 as the common factor. You can see that automatically. So I know I can pull out the 2x plus 3. And the other factor would be these numbers that are on the outside, x squared minus 4. Equal 0. All right, but that x squared minus 4 is what we call the differences of two squares. That can be factored into two binomials. So let's bring down the 2x plus 3 and factor x squared minus 4, since that's the difference of two squares. That x squared can be broken up as x and x. What number times itself gives me 4 has to be 2 and 2. Now, since it's a difference of two squares, one has to be plus, the other one has to be minus. It's just a rule for factoring differences of two squares. So 2x plus 3 times x plus 2 times x minus 2 equal to 0. This is factored completely. Now we're going to set each of these binomial factors to be equal to 0. So this means 2x plus 3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. And then for each one of these, we're going to solve for x. So for the 2x plus 3 is equal to 0. If I subtract 3, you're going to get 2x is equal to negative 3. And then divide both sides by 2. That means x is equal to negative 3/2. And then for the x plus 2 is equal to 0. If I subtract 2 on both sides, that means x is equal to negative 2. And then for the x minus 2 is equal to 0. If I add 2 to both sides, you'll get x is equal to 2. So these are my solutions to this polynomial equation, which is this. We got x equal negative 3/2, x equal negative 2, and x is equal to 2. All right, now the highest exponent, as you can see, is a 3. That means I must have 3 solutions here. And in this case, I do. Negative 3/2, negative 2, and positive 2. All right, so that's how we solve polynomial equations by factoring. Okay, now let's look at radical equations containing nth roots. So we're going to be looking at equations where there is a radical sign, or radical, an expression underneath a radical, as I should say. Okay, now here's the procedure for that. And by the way, the equation of before I do that, let me define what a radical equation is. It's not in this handout that I have here, but here it is right here, where it says solving radical equations. Here's the definition. A radical equation is an equation in which the variable is under the radical symbol. So like in this case here, if I have the square root of x equals to 9, well, if I want to solve for x, the opposite of taking the square root would be to square both sides. If you recall, the opposite of squaring something would be to take the square root. Well, if you have the square root, the opposite would be to square both sides. That eliminates the radical. So the square root of x and u squared will take whatever's underneath that radical out. So the x will come out of the radical. So you just have x, then that'd be equal to 9 squared, or 9 times 9, which is 81. Okay, that's pretty much how you'll solve a radical equation. And that one was kind of simple. Okay, but here's the procedure for more complicated radical equations containing nth roots. Number one, you want to arrange the terms so that one radical is isolated on one side of the equation. And then number two, you're going to raise both sides of the equation to the nth power to eliminate the nth root. And then number three, you're going to solve the resulting equation. And then number four, check all proposed solutions in the original equation, because you want to make sure that you eliminate any values of x where it does not satisfy that equation. Okay. Now here we're going to be dealing with the square root in these examples here. So when raising both sides of an equation to an even power, like to the second power or to the fourth power, you want to always check the proposed solutions in the original equation. Extra solutions may be introduced when you raise both sides of a radical equation to an even power. Such solutions, which are not solutions of the given equation, are called extraneous solutions or extraneous roots, because you might have that. Okay, so like in this example I'm going to show you, let's say we want to solve and check. In this case here, we got the square root of 20 minus 8x equal to x. Okay, the square root of 20 minus 8x equals x. And here I want to solve and check. Well, in this case here, the radical is already by itself. So the opposite of taking the square root would have to be to take the square on both sides of this equation. And this x will have to be squared as well on the other side. Now, when I square both sides, that's going to eliminate the square root symbol. So in this case, the square root of 20 minus 8x, and u squared will be what's underneath that radical, 20 minus 8x. That's equal to x squared. And then next, we're going to get a 0 on one side of this equation. That means I need to move 20 minus 8x over to the opposite side. And I'm going to do that by adding 8x first, and then also subtracting 20 on both sides, because I want to get a 0 on one side of this equation, which I have here, because the 20 and the minus 20, they're gone. Minus 8x and plus x, they're gone. Plus 8x, they're gone. You're left with 0. And that's equal to x squared plus 8x minus 20. And now I've got a quadratic expression that I can factor into two binomials here. So x squared factors into x and x. And then I need factors of negative 20 that would give me 8x as a middle term. That would mean one has to be plus, the other one has to be minus. And the larger of the two factors will take the sign of the middle term. So if I use 10 and 2, I have to make the 10 a plus and the 2 a minus. That way, the outer, which is negative 2x, plus the inner, that's 10x, will give me the middle term of 8x. So factored completely, that would be x plus 10 times x minus 2 equals 0. And then we're going to set each binomial factor equal to 0 and solve. So x plus 10 times x minus 2 equal to 0 means x plus 10 equals 0, or x minus 2 equal 0. And then each equation will solve for x. So for the x plus 10 equal to 0, that means if I subtract 10, that will mean x is equal to negative 10. Or for x minus 2 is equal to 0, if I add 2, that will be x is equal to 2. So these are my two proposed solutions, x equals negative 10 or x is equal to 2. Those are not the actual solutions, because notice in this original equation, the highest exponent is a 1. That means that there is only one solution, and one of them has to be the real solution to that radical equation. So here is where we do the check. And I'll start with x is equal to negative 10. And I'm using the original equation, the square root of 20 minus 8x is equal to x. And I'm going to substitute the x with negative 10. So on the left side, I got the square root of 20 minus 8 times negative 10. I want to know if that's going to be equal to negative 10. Let's simplify this. 20, and then minus 8 times a negative 10 will be a plus 80. I want to know if that's going to be equal to negative 10. 20 plus 80 is 100, so the square root of 100, I want to know if that's going to be equal to negative 10. If I take the square root of 100, that's just 10. And is 10 equal to negative 10? It's not. So that is a false statement. Okay, so that means for x equal negative 10, that's what we call our extraneous solution. So we need to cross out that extraneous solution. Okay, and now for the x is equal to 2, that means I have to do the square root of 20 minus 8 times x, which is 2, equal to x, which is also going to be 2. I'm just substituting 2 in for x in the original equation. And then I'm going to simplify the left-hand side. This will be the square root of 20 minus 8 times 2, that's 16. Want to know if that's going to be equal to positive 2. Well, 20 minus 16 is 4. So is the square root of 4 equal to 2? Well, if I take the square root of 4, that would be 2. That is equal to 2. So this is a true statement. So in this case, x equals 2 is the solution to that rational equation, or I should say radical equation. Okay. Okay, here's another example of a radical equation. Let's say we had this. Here I want to solve this, the square root of x plus 3, and then plus 3 is equal to x. Okay, so here I'm going to write this out, but I first have to get that square root of x plus 3 by itself before I do anything. Here I'm adding 3, so I need to subtract 3 on both sides. So that means I have the square root of x plus 3, and that's equal to x minus 3. Okay, and since I got that radical by itself, the opposite of taking the square root would be to square both sides. Okay, and when I square both sides, this eliminates the radical. So the square root of x plus 3, and our squared will be what's underneath that radical, x plus 3. Now let's look at that x minus 3 quantity squared. We need to multiply that out. So on the side, I'm going to write this out. I know that x minus 3 is used as a factor twice, so I'm going to write x minus 3 as a factor 2 times, and then use the FOIL method. So in this case here, if I do the first times the first, that's x times x, that's x squared. And then the outer will be x times a minus 3 will be minus 3x. The inner minus 3 times x will be minus 3x. And then the last times the last minus 3 times the minus 3 will be plus 9. And then from here, just go ahead and combine the like terms. So this will be x squared, negative 3x, and negative 3x is minus 6x plus 9. So that's what x minus 3 quantity squared will be, x squared minus 6x plus 9. And now I'm going to get a 0 on one side of the equation and by moving all these two terms over to the opposite side. So for the x plus 3, I'm going to subtract x on both sides. And I'm going to subtract 3 on both sides. I have to do that because x minus x, that's gone. Plus 3 and a minus 3, that's gone. You're going to get a 0 on the left side. Now on the right side, this is what you'll get. X squared. And by the way, notice I did put the like terms underneath each other. So minus 6x and a minus 1x, that's minus 7x. And then 9 minus 3 will be plus 6. So I get x squared minus 7x plus 6 is equal to 0. And then next I can factor x squared minus 7x plus 6 into two binomials here. So that x squared will be broken up as x and x. The middle term is a minus, the last term is a plus. That means both have to be minus signs. And the factors of 6 that give me 7x as a middle term has to be 6 and 1. Negative 6x and a negative 1x will give me negative 7x. So I get x minus 6 times x minus 1 is equal to 0. And now we're going to set each binomial factor equal to 0. So x minus 6 times x minus 1 equal to 0 means x minus 6 equals 0, or x minus 1 equals 0. And each equation we're going to solve for x. So for the x minus 6 is equal to 0, if I add 6, this will be x is equal to 6. Or for the x minus 1 is equal to 0. If I add 1, you're going to get x is equal to 1. So these are my two proposed solutions, x equals 6 or x is equal to 1. But one of them is the real solution. So this is where we do the check for each of those proposed solutions, starting with x is equal to 6. And my equation is the square root of x plus 3, and then plus 3 equals x. So I'm going to substitute each x with 6 in this equation. So I have the square root of 6 plus 3, and then plus 3 is equal to 6. 6 plus 3 is 9, so I have the square root of 9 plus 3. That should equal to 6, and I'll put question marks there on top of the equal sign. The square root of 9 is 3, so does 3 plus 3 equal 6? And it does. 6 does equal to 6. That checks. So that means here, x equals 6 is the solution to that radical equation. And just to verify that x equals 1 is not solution, I'll go ahead and check that as well. So the square root of x, I'm going to substitute with 1 plus 3, and then plus 3 on the outside should equal to x, which I'm substituting with 1. 1 plus 3 is 4, so the square root of 4 plus 3, that's going to be equal to 1. The square root of 4 is 2, and does 2 plus 3 equal to 1? Well, if you add 2 plus 3, you're going to get 5. So here I have a false statement. And I might as well say that this is true here. Well, since at x equals 1, we're going to get a false statement. So that means that x equals 1 is your extraneous solution. So the only solution for that radical equation will be x is equal to 6. Okay. Okay, so that's how we solve radical equations. Okay. Now let's look at equations with rational exponents. All right, in this case here, expressions with rational exponents represent radicals, like this one. A to the m over n. Here we got a rational exponent. The exponent is in the form of a fraction. We can write that as this: the nth root of a raised to the m power. The n is the index for the radical. The m is the exponent for that radical. Or another way we can write that would be something like this: the nth root of a, where the m is the exponent for that a. So these are just two ways of writing rational exponents that can be represented as radicals. Now, a radical equation with rational exponents can be solved by isolating the expression with a rational exponent and raising both sides of the equation to a power that is the reciprocal of the rational exponent. Okay? And what I mean by reciprocal, if I have 2/3, the reciprocal, you just flip the fraction over, there'll be 3/2. That's what we mean by the reciprocal. Okay. Now let's say I want to solve a radical equation of this form: x to the m over n equaling to k. And we're going to assume that m and n are positive integers. M over n is in lowest terms. That means it's already in simplest form. And k is a real number. The first step is to isolate the expression with a rational exponent. That means move terms over to the opposite side. And then number 2, raise both sides of that equation to the n over m power. That's the reciprocal. M over n is the fraction. its reciprocal is n over m. So you're just going to raise both sides to that power. Now, there are two cases that you're going to have. If your m, which is the numerator, is an even number, like 2, 4, 6, 8, and so on, this is where you have to use the plus or minus symbol. Notice here on this side right here, if your m is an even number, the numerator is even, you have to use the plus or minus symbol. But if m is odd, you're not going to use that plus or minus symbol. Notice that there's no plus or minus symbol there on the right side. So m, which is your numerator, is an even number. That's when you use the plus or minus symbol. But if it's odd, you don't. Okay. Now, it is incorrect to insert the plus or minus symbol when the numerator of the exponent is odd. An odd index has only one root. Okay. And then number 3, you're going to check all proposed solutions in the original equation to find out if they are actual solutions or extraneous solutions. Okay. Now, here's how you're going to know when to check and when not to check. And I'm writing this in. If n, which is going to be the denominator, is even, this is where you're going to check the proposed solution. But if n, again, that's the denominator in the original equation, is odd, you do not check the solution. Okay. All right. So hopefully this will help you determine whether or not to do the check. So let's start with this example, part A. So here we're going to solve, and we're going to determine whether we need to do the check or not. Okay. So here we've got 5x to the 3 halves minus 25 is equal to 0. Okay. Now, let's take a look at that exponent of 3 halves. Let's take a look at that exponent of 3 halves. The numerator, I can see, is odd. The denominator is even. And as we stated, if your n, that's your numerator, if it's odd, then that means you're not going to need the plus or minus symbol. Here's your denominator, 2. That's an even number. So that denominator is even. You will have to check the proposed solution. So here I'm going to make mental notes here. Do not use a plus or minus symbol. Do check your solution. Okay. So now let's start by solving this equation here. All right, I need to move the minus 25 over by adding 25 on both sides. So that means I have 5x to the 3 halves is equal to 25. And then divide both sides by 5. That would mean x is equal to 3 halves. X to the 3 halves is equal to 5. X to the 3 halves is equal to 5. And then next would be to raise both sides of this equation by the reciprocal of this. So if this is 3/2, the reciprocal of 3/2 will have to be 2/3. So I'm raising both sides of this equation to the 2/3 power. And when I do that, what's going to happen here is that these 2's and these 3's divide out. You're going to be left with x by itself. That's equal to 5 to the 2/3. And in this case here, if I write that in the form of a radical, this is what I'll have. The 3 in the denominator will be the index. The 5 goes underneath it, and the 2, which is my exponent, it'll be the exponent for 5. So it'll be the cube root of 5 to the second. And 5 to the second is 25. So I can simplify that as the cube root of 25. Now notice that it does say check. So that means I need to take my original equation and check this proposed solution. I'll rewrite the equation. And then substitute the x with, I'm going to use the rational form of the cube root of 25, 5 to the 2/3, because my exponent is in the form of a fraction. So I have 5 times, substitute the x with 5 to the 2/3, raised to the 3/2, minus 25 equals 0. Now when I do that, these 2's divide out and the 3's divide out. You're just left with 5 to the first power of just 5. So I have 5 times this 5 minus 25. I want to know that's equal to 0. Well, 5 times 5 is 25. And 25 minus 25 is 0. So that checks. So here my solution would just simply be the cube root of 25. That's all there is to it. All right, here's another example. Let's say I had this. X to the 2/3 minus 8 is equal to negative 4. You'll want to solve this. All right, now let's take a look at that 2/3, which is my exponent. The 2 in the numerator is even. The 3 in the denominator is odd. Since it is even, the numerator is even, I do need to use the plus or minus symbol. The denominator is odd, because that's like the cube root. So here I do not check the proposed solution. So I just say no check of the proposed solution. But here I do need to use a plus or minus symbol since that numerator is even. All right, so now let's solve this equation. X to the 2/3 minus 8 is equal to 4. Let's get x to the 2/3 by itself by adding 8 to both sides. So that means x to the 2/3 is equal to negative 4 plus 8 will be 4. X to the 2/3 is equal to 4. Since I got that rational part by itself, what I need to do here is raise both sides to the power that's the reciprocal of this. The reciprocal of 2/3 will be 3/2. And that 4 is going to be to the 3/2 power as well. So now these 2's divide out and the 3's divide out. I'll end up with just x by itself. And I also need to include the plus or minus symbol as well. Okay. So I need plus or minus here because I have to use a plus or minus here because of the numerator being even. Let's see, 4 to the 3/2 power. Another way of writing that would be plus or minus. If I wrote it in radical form, it'll be the square root of 4 to the third. And then if I simplify 4 to the third power, that will be 64. And then bring up the plus or minus, the square root of 64 is 8. So here x is equal to plus or minus 8. And here I do not do the check because the denominator is odd. So there's no need for the check here in this equation. So the solution there is positive 8 and negative 8. Okay. Okay. There's a couple of more examples just like that. Let's say we had this. We want to check all the proposed solutions here and solve the equation. 9x to the 7/3 is equal to minus 45 equal to 0. All right, now let's take a look at the 7/3, which is my exponent. As you can see, both the numerator and the denominator are odd. They're both odd. Since the numerator is odd, that means I do not need a plus or minus symbol. The denominator is also odd, so I do not check. So I just say no check here. Okay. So now let's solve this equation by getting the rational exponent by itself. I'm subtracting 45. I need to add 45 to both sides. So that means I got 9x to the 7/3 equals 45. And then to solve for x, divide by 9. Or to get x to the 7/3 by itself, I'll divide both sides by 9. That would mean x to the 7/3 is equal to 5. Okay. So next, I'm going to raise both sides of this equation by the reciprocal of 7/3, which is in this case 3/7. So this will be raised to the 3/7 power, and then the 5 will be raised to the 3/7 power. And what will happen is the 7 and the 3's are gone. You'll be left with just x. That's equal to 5 to the 3/7 power. And if we were to write that in radical form, that 7 would be your index. And then the 5 would go inside the radical. The 3 would be your exponent for the 5. So it would be the 7th root of 5 to the 3rd. And I think 5 to the 3rd is 5 times 5 times 5, which is 125. So it'd be x is equal to the 7th root of 125. Okay. And of course, we don't do the check here. So we're done with this problem. X is equal to the 7th root of 125. And of course, we don't need the plus or minus symbol because our numerator was odd. Now, part B, let's say we got x minus 3 raised to the 2/3 is equal to 49. Here, I want to solve this equation. Well, let's take a look at that 2/3 here. That's the exponent. The numerator in 2/3 is even. The denominator is odd. Well, the 2 is even, that numerator is even. That means I do need to use a plus or minus symbol. The denominator is odd, so I need not to do the check. So do not check, but use the plus or minus symbol. All right, so now let's solve this. We need to get rid of the 2/3 here by raising both sides to the reciprocal of 2/3. Which is 3/2. And then that's equal to 49 raised to the 3/2. And then what's going to happen here is this. The 2's and the 3's divide out. You're only going to be left with x minus 3. And that's equal to, and of course, I'm going to include the plus or minus symbol here. Let's see, 49 to the 3/2. I can write that as the square root of 49. And that's going to be cubed. Now, what's the square root of 49? That's going to be 7. So I get x minus 3 equals plus or minus 7 raised to the 3rd power. And then 7 to the 3rd power will be 7 times 7 times 7, which would be 343. So I get x minus 3 is equal to 343. Now that plus or minus means I got two equations. One of them would be x minus 3 is equal to positive 343, or x minus 3 is equal to negative 343. Now to get x by itself, we're going to add 3 to both sides on this first equation. That would mean x is equal to 346. Or for the x minus 3 is equal to 343, you'll add 3 to both sides. You'll get x is equal to negative 340. So in this case here, your solution is going to be this, 346 or negative 340. And of course, we don't do the check here. Now, this right here, that 49 to the 3/2 power, you could have did that in the calculator if you wanted to by doing this. Typing in the number 49 and then hit the hat key for your exponent, and then type in 3 divided by 2 and then hit enter. You'll get 343. And you have to include the plus or minus anyway. Okay. All right, next we'll look at this concept where we have equations that are quadratic in form. Quadratic in form. Some equations that are not quadratic can be written as quadratic equations using the appropriate substitution. Like in this case here, we're given x to the 4th minus 8x squared minus 9 equal to 0. An appropriate substitution for that would be something like this, using u is equal to x squared. And then you have something like this, x squared raised to the 2nd minus 8x squared minus 9 equal to 0. And then that new equation would be u squared minus 8u minus 9 equal to 0. That would be quadratic in form. And by the way, if you think of letting u be equal to x squared, that would mean if I square both sides, u to the 2nd would be equal to x squared, and I square it, it will be x to the 4th. And then you'll be able to make that appropriate substitution. Now for fractions like this one, 5x to the 2/3 plus 11x to the 1/3 plus 2 equal to 0. The appropriate substitution for that one would be something like this. Let the u be whatever this middle term is, u to the 1/3. And then if you square both sides, you'll have u squared is equal to x to the 2/3. And then you'll make your appropriate substitution in terms of u to get 5u squared plus 11u plus 2 equal to 0. Okay. All right. An equation that is quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. Equations that are quadratic in form contain an expression to a power, the same expression to that power squared, and a constant term. By letting u equal to the expression to the power, a quadratic equation in u will result. Then you'll solve this quadratic equation for u, and then finally use your substitution to find the value for the variable in the given equation. And I also have a procedure here that I'm going to go ahead and share with you. And that's this right here. When you have equations that are in quadratic in form, the procedure there will be to let u equal to the variable of the middle term. And then you'll square both sides to find u squared. And then substitute u squared and u in the original equation. And then factor completely and solve for u. And that should be solved for you, not solve of u. Solve for u. Then use the substitution to find the values of the variable in the original equation. Okay. So we can use that procedure to help us solve equations that are quadratic in form. And if you'd like to, you can pause this video to copy down that procedure in your notes. Okay, let's look at example 6. Let's say I want to solve this equation, x to the 4th, and I'll write it again, minus 5x squared plus 6 equal to 0. Okay. Now here's what we're going to do here. We're going to let u be equal to the variable of the middle term. Here's the middle term right here. That variable is x squared. So I'm letting u equal to x squared. Now here's what I'm going to do here. Since u is equal to x squared, I'm going to take the square of both sides of this equation. Oops, it should be the square of both sides, not to the 4th. So u squared would be u squared. Then x to the 2nd raised to the 2nd. When you raise a power to a power, you multiply your exponent. So u squared will be equal to x to the 4th. Okay, so this is what we're going to do here. That x to the 4th will be substituted with u squared. Minus 5 times that x squared will be substituted with u, because we're letting u equal x squared. And then bring down the plus 6 equal to 0. So now we have an equation that is in the form of a quadratic. U squared minus 5u plus 6 equal to 0. Now in this case, we can factor this into two binomials. So u squared factors out as u and u. The middle term is minus, the last term is a plus, so I need two minus signs there. And I need factors of 6 that's going to give me a middle term of 5u. So it has to be 2 and 3. So factored, it would be u squared, u minus 3 times u minus 2 times u minus 3 is equal to 0. And then you'll set each binomial factor equal to 0 and solve. So here you're going to have u minus 2 equal to 0, or u minus 3 equal to 0. And then we solve for x. So for the u minus 2 is equal to, for u. So for u minus 2 is equal to 0, that means u is equal to 2. Or for u minus 3 is equal to 0, that means u is equal to 3. Now we don't stop right here because we started off as an equation in terms of x. Our answers have to be in terms of x. Okay? Now notice we've already let u be equal to x squared, so I need to substitute the u with x squared. So this will be x squared is equal to 2. And also that u was x squared. It would let u be x squared, so that means x squared has to be equal to 3. And then for each equation, we'll solve for x. So start with the x squared is equal to 2. We take the square root on both sides and include the plus or minus symbol. So that means x is equal to plus or minus the square root of 2. And then for the x squared equal to 3, we take the square root on both sides and include the plus or minus. So that means x is equal to plus or minus the square root of 3. Okay. Okay. So you want to make sure that you do the back substitution. Whatever u was, you substitute that in for u to get your answers in terms of x. So here the solution for that would be square root of 2, negative square root of 2, square root of 3, negative square root of 3. And of course, our highest exponent was a 4, so we would expect to get 4 solutions, and we did. All right, here's another example. Let's look at the one that has fractions in the exponent. So here we got 3x to the 2/3 minus 11x to the 1/3 minus 4 equal to 0. Now, in this case, this is what we need to do here. We're going to let u be that variable of the middle term. That's the x to the 1/3. So we're letting u equal to x to the 1/3. Now, if I square both sides, that means if I square the u and square the x to the 1/3, this will be u squared, and this will be equal to x to the 1/3 times 2/1 would be 2/3. So now we can make our appropriate substitution. So here I'm going to bring down the 3, and that x to the 2/3 is what u squared will be. So it'll be 3u squared minus 11 times the x to the 1/3 will be u, because we let u be equal to x to the 1/3, and then minus 4 equal to 0. So now I have this written in the form of a quadratic equation, 3u squared minus 11u minus 4. And that's equal to 0. So now I can factor this into 2 binomials. Let's see, 3u will have to be broken up as 3u times u. And then we're going to have to find factors of -4. I know that's going to have to be something like -4. 4 and 1 would work, because if I put the 4 here and the 1 here, and that middle term is a negative, so that means this 4 will have to be a minus, and the 1 has to be plus, because you have to put the plus sign and the minus sign and your constant terms in a way so that the outer and the inner will give you the middle term. In this case here, minus 12u plus 1u will be negative 11u. So I got 3u plus 1 times u minus 4 equal to 0. And then we set each binomial factor equal to 0. So in this case, I'll set 3u plus 1 to be equal to 0, or I'll have u minus 4 equal to 0. And each equation we're going to solve for u. So for the 3u plus 1 equals 0, that means 3u is equal to negative 1. Divide by 3 on both sides. U is equal to negative 1/3. And then for the u minus 4 is equal to 0, I add 4. That means u is equal to 4. Now you can't end that problem right there because it began as an x, as a problem in terms of x. We need to end it in terms of x. So that u was equal to x to the 1/3. So we're going to substitute the u with x to the 1/3. And that's equal to negative 1/3. And the u equal to 4, well, we let u equal x to the 1/3, so we substitute x to the 1/3 in for u. And for each equation, we're going to solve for x. Well, the rational part is already by itself, so we're going to raise the left side and the right side to the reciprocal of 1/3, which is 3/1. And that negative 1/3 will be raised to the 3/1. And what's going to happen here is the 1s and the 3s divide out. You will be left with x. And that's equal to negative 1/3 to the 3rd power, which is actually negative 1/3 cubed. I can cube the numerator and cube the denominator. Negative 1, and you cube it is negative 1, over 3 cubed. 3 times 3 times 3 will be 27. And now for the x to the 1/3 equal to 4, raise both sides to the reciprocal of 1/3, which is actually 3. Threes divide out, you'll be left with x to the 1, or just x. And then 4 to the 3rd is 4 times 4 times 4, which is 64. And that's all there is to it. So the only two solutions will be negative 127 and 64. Okay. All right. And finally, we're going to be dealing with equations involving absolute value. Equations involving absolute value. So the way we're going to rewrite an absolute value equation without the absolute value bars is going to be this. If C is a positive real number and capital letter X is any algebraic expression, then the absolute value of X equaling to C is going to be equivalent to this. X is equal to C, or X is equal to negative C. X is equal to C, or X is equal to negative C. You'll have two equations to write. Each equation you'll solve for X. So like in this example here, let's say we have the absolute value of 2x minus 3 is equal to 11. Well, notice that the absolute value is already by itself. So that means we're going to follow this procedure right here and write two equations for that. The first one will be 2x minus 3 equals 11, or 2x minus 3 equals negative 11. And each equation we will solve for x. So for 2x minus 3 is equal to 11, if we add 3, you'll get 2x is equal to 14. And then to solve for x, we have to divide both sides by 2 to get x is equal to 7. Or for the 2x minus 3 is equal to negative 11, we're going to add 3 to both sides to get 2x is equal to negative 8. And then divide both sides by 2. X is equal to negative 4. So here, I'm going to have two solutions here. X equals 7 or x is equal to negative 4. Now, if you wanted to, you can take the time and do the check on each one of those proposed solutions. Okay. All right. Let's say we have something like this. Absolute value of 2x minus 1 is equal to 5. Absolute value of 2x minus 1 is equal to 5. And here I want to solve this equation for x. So here, the absolute value is by itself, so that means we can go ahead and write out two equations. That first equation is 2x minus 1 is equal to 5, or 2x minus 1 equals negative 5. And each equation we will solve for x. So for the 2x minus 1 equaling to 5, if we add 1, you'll get 2x is equal to 6. And then divide both sides by 2. X is equal to 3. Or for the 2x minus 1 equal negative 5, of course, if we add 1, this time it'll be 2x is equal to negative 4. And then divide both sides by 2. X is equal to negative 2. So the solution there will be 3 and negative 2. Okay. Now, let's say here, our equations were written somewhat like these two here. These are cases where you must isolate the absolute value equation first before you start to write your two equations. So like in this example here, we got the absolute value, 7 times the absolute value of 5x plus 2 is equal to 16. Okay, let's say we had that. First of all, we need to isolate the absolute value of 5x. That means I need to get rid of the 2 and get rid of the 7 that's in front. Let's get rid of the plus 2 by subtracting 2 on both sides. That would mean I have 7 times the absolute value of 5x equals 14. And then to get the absolute value of 5x by itself, I'm multiplying it by 7. So I need to divide both sides by 7. So we got the absolute value of 5x equals to 2. And now we can go ahead and write our two equations. The absolute value of 5x equals to 2 means this. 5x equals 2, or 5x is equal to negative 2. And then we go ahead and solve each equation for x. So for the 5x equals 2, if I divide both sides by 5, you'll get x is equal to 2/5. Or for 5x is equal to negative 2, divide by 5. This time you'll get x is equal to negative 2/5. So in this case here, your two solutions are 2/5, negative 2/5. Okay. All right, and the other example here. Let's say we got the absolute value of 4 times the absolute value of 1 minus 2x minus 20 equal to 0. So again, we need to get the absolute value by itself. Okay, so that means I need to move the minus 20 and then get rid of the 4 that's in front. Let's get rid of the minus 20 by adding 20 on both sides. So that means I have 4 times the absolute value of 1 minus 2x is equal to 20. And still I need to get absolute value of 1 minus 2x by itself. I'm multiplying it by 4, so I need to divide both sides by 4. So that means I got the absolute value of 1 minus 2x is equal to 5. And now, since the absolute value is by itself, we can go ahead and write our 2 equations. The first equation will be 1 minus 2x is equal to 5, or 1 minus 2x equals negative 5. And then for each equation, we'll solve for x. So for the 1 minus 2x is equal to 5, I need to subtract 1 on both sides. So it'll be negative 2x is equal to 4. Divide both sides by negative 2, you'll get x is equal to negative 2. Or for the 1 minus 2x is equal to negative 5, still I need to subtract 1 on both sides. So now negative 2x then will be equal to negative 6. Divide by negative 2 on both sides. X is equal to positive 3. So my 2 solutions here will be negative 2 and 3. Okay. Now I do need to end this video with a couple of special cases here. All right. Case number 1 is this: if you have the absolute value of x equaling to a negative constant, that means that there is no solution. So like in this case here, if I have the absolute value of 3x minus 2 equal to negative 7, I'm not going to be able to solve that absolute value equation because it will have no solution. Keep in mind that absolute value is always going to be positive. There is no value of x where the absolute value of 3x minus 2 would give me negative 7 as an answer. So this would be no solution. Case number 2 is where the absolute value of x equal to 0 can just easily be found by just simply solving the equation x is equal to 0. So if you have an equation like x minus 2 equal to 0, all you have to do there is just solve x minus 2 is equal to 0, because absolute value of 0, of course, is 0, and 0 is neither positive nor negative. Okay? So that will conclude this video on section 1.6, dealing with other types of equations. And again, feel free to email me if you have any questions about anything presented in this video or any questions presented in the homework on my math lab.